Great. So we're here at week 2 of the RAILect series. And today's topic is on demystifying data science.
Absolutely. And this is a topic which I've been talking about this in many different contexts. And so I'm really quite looking forward to going through and actually giving a sort of lecture on this for a change.
Well, and I guess that's it, is it's so relevant across to so many different groups of people at the moment on demystifying it, because it comes across as such a this is the exact same talk you gave to me to help me to help demystify it to me, more or less, with some tweaks here or there.
Yeah.
At least the first few examples, and it's interesting how relevant that is across different fields.
Exactly. And this is where, for the last couple of years, since really generative AI hit the scene, there's been a real need for this, because there's so many misunderstandings which are coming out and so much hype. And the point is that, yes, this is powerful stuff. It's so important. But if we don't understand what it can do, we don't understand its limitations and also where we are as a society in the use of it and how we should be thinking about it.
Absolutely. So I thought, in case, there we go. I know that we discussed this slide last week. I know that we've been through this already, but just as a recap, because it just feels so relevant right now.
And it's really at the heart of our course is this research, which is one of the reasons that it's just the right time to be trying to help lecturers come to terms with AI and think about using it responsibly.
Yeah. And so this is the study from the University of Reading. I'm sorry if it's being repeated for the kind of 5th, 6th, 7th time in this course so far, but anyway, the study from the University of Reading, where they had kind of the 33 like fake students, which examiners were given reports from them or answers from them which were AI generated.
Yep.
And 2 of them went undetected.
So 2 of them, 94%, so 31 went undetected, and only 2 got detected.
Yes, sorry. And then also for the first and second year modules, the AI tended to perform better on average than the actual real students, or tended to get, maybe not perform better, but were graded higher.
Yes.
On average. And then when we get to the third years, or the third year module, now that there's this more critical thinking coming in and whatnot, the AI does not perform as well on average as the students.
And that could be the nature of the module, or it could be the nature of the students. And I think in some sense what is critical, again, in terms of actually just when we're getting towards the demystifying AI, this generative AI, which I would argue this is also an evidence of the AI passing a Turing test type scenario, where you have the interactions between humans and humans in terms of students and examiners, and AI and humans, which is the generated answers and the examiners, and you have the researcher who's the external observer observing that, and this is something where they're observing, they're not able to sort of really check to see whether the examiners, the people interacting with it are using it or not. It's not quite relevant to the Turing test, but it is something where it comes back to this fact that really AI has got to a level where we can't easily identify it, hence so many of these going undetected.
I wonder as well if there were any false detections as well, any kind of...
We didn't get that, yes, but we know in other contexts with other studies the issues caused by these false detections. And so we've talked before about both, worrying about the false positives and the false negatives. So I think this is, again, to start this demystification of AI. These generative AI structures are obviously exceeding our expectations in certain ways at this point in time, in terms of the systems that we have in place. And so they're being disruptive to our systems. In higher education, this can be our assessment systems, our examination systems. And the advances made by generative AI are disrupting those systems. And so understanding really what it is and why they've been able to reach this point where they've disrupted them so recently, despite being around for so long and as not worrying about them before, I think is important as part of, just making sure we understand, well, what's actually going on here.
Absolutely. And so to go into the demystification on the Moodle page, we do have a little bit on the kind of background of AI and as you mentioned, the Turing test, which came from the kind of Dartford conference in 1956, which kind of, I guess, shows the history of how long.
Almost 70 years. It's amazing.
It's incredible. And it's only recently that people have thought or have started to think, okay, we might be at that kind of turning point now with generative AI. But yeah, we have a little bit on the background of it in the on the Moodle page, just if anyone's interested in it, in case that helps to also demystify it, to know kind of where it's come from.
Yeah. But I don't want to spend too long digging into that history and how it's changed. We will discuss the advances made in the 90s. They will come out because that's important. But I think we're going to look at this really through the lens of these case studies, which are also highlighted in the course materials.
Yeah, absolutely. And so I mean, David, you were the one that said it's kind of about the power and limitations, which I really love. I love that because there is so much power behind it. And I guess that's where we start with your post office example, which I think really helps show the kind of power that we get from AI.
And you say this is my example. This is not my example. This is standard textbook, now, and I guess I mentioned this has come out of the advances made in the 90s, deep learning. And of course, just like has happened now, but a bit differently, AI hit the headlines in the 90s because it won at chess. And that was the sort of public appreciation of the advances that were made. The fact that a deep learning machine could beat grandmasters at chess was.
Yeah, I was going to say it's not that it only won at chess; it beat the grandmaster at chess. I think it was called Deep Blue or something was in it. I can't remember.
I think it was Deep Blue was the what was the first, I believe, AI chess player to win against the top grandmasters of chess. And this is a really, really big deal. And what was very interesting is that actually there's a whole saga that went on around this where they've actually played each other multiple times. And there was a bit of backwards and forwards at the beginning. And then, the AI could win. And this is sort of relevant because in the post office example, which highlights what's going on, they use the same learning mechanisms, the same deep learning mechanisms to be able to read postcodes. And this is what transformed post offices, from having very human sorting machines to these automated machines, because you could, at speed, images could be analyzed to be able to sort the mail according to the postal codes. How did it do that? Well, I mean, the first thing it did is it transformed what was human writing, an image of human writing, into a set of dots, black, white, dots, which it then was able to sort of do pattern recognition on to be able to classify them. Sort of say if it had this sort of configurations of dots, then it would be classified as this letter. Now, of course, what's complicated is the nature of the deep learning algorithms means that the exact specification of what is classified as what letter we don't have. but it's built into the way it's learned, how it's doing these classifications in terms of the mathematical transformations which are happening beneath. But at the essence, there is this element of actually having this data which is fed in, which has created the algorithms. There's been the learning then, where their classifications of things correctly classified have been given to help the system learn. And then there are systems in place so that if a letter gets misclassified, it gets fed back in with a correction, and that will help the system to continue to learn and improve as it goes on. And this is at the heart of what makes any machine learning algorithm, any artificial intelligence system, really. You should be thinking about what data are you feeding in, what's the algorithm doing, and how are you putting in place these mechanisms for it to continue to evolve and continue to learn based on how people are using it and how it's used. And in the post office, this works beautifully because although initially, I think the success rate was was it about 90%?
Approximately 90%, yeah, at first, I think.
Which is lower than the humans were doing. I mean, human sorters were doing better than that. What was it? 95% was about what you would get from good human sorters?
About 95% from good human sorters, about 90% from the machine.
From the machine. But of course, the machine reduced costs. But more than that, because it's a good AI system where the errors are feeding back in, there has been continued learning over time. And that continued learning has led to the fact that now the machines are 99% plus.
Yes.
No, they're better than 99% accurate, better than you could ever dream of getting humans to do. And that's really possible because this it's not just about what the algorithms were able to do with the data that was provided at the start. It's also how they were put in place these mechanisms so that when things went wrong, humans were able to intervene, identify those errors, and feed them back into the system and lead to further learning for the system. And that learning is therefore not stuck with an individual who gets better and better, but the system as a whole is now improved.
And that's definitely the key point. But just to add a little, I guess, tidbit. I mean, this would have been implemented around about 30 years ago. And if we imagine it, the alternative is that a human works in it for about 30 years. I mean,
coming to retirement age.
Yes, exactly. Eventually they would retire. They would leave their job for whichever reason. Whereas and you can't kind of transfer that knowledge between humans.
You can have training from one human to another, but you're sort of starting again in terms of actually building up those skills. And actually that continued learning, you probably find that actually it doesn't continue, humans don't continue to get better and better. They tend to peak and then have a slow decline. With most tasks which are repetitive. And so this is the sort of thing where I would expect that as we think about how AI is already integrated into our society, in many cases, it will look a lot like this, where actually there are tasks which would have been very repetitive, which have been instead replaced by AI algorithms, and that's led to considerable efficiencies within many different industries. But a lot of it has been behind the scenes. I think if we go to our next example, and I think maybe the one thing to finish off as we go to the next example is that these advances are really still rooted in the 90s. It's the deep learning advances, and it's the AI if you want, which was classification AI, which was regression AI, if you want, as opposed to thinking about it as generative AI, which we'll come into, by the end of this to discuss a bit further. But we're going to really hone in on these sorts of more traditional elements of AI and understanding the powers and the limitation. So The next example I'd like to go to is the birdsong. And I don't know whether people have used apps to identify birds, but they're really powerful. They're great. My aunt loves them. She sticks them out in the garden and sort of looks for the things. Oh, I didn't realize I had a red cardinal here. Oh, yeah, there it is. And so she loves using this to actually understand, what birds she's attracting into her garden and sort of. I think it's very healthy for the birds as well because it means she leaves out lots of food all the time. Um, so bird food is an important part of this ritual.
That's a
But
great point. Yes, very good point. I've
but
meanwhile got no battery, so I am still here. But
the at the heart of this process of training these apps is the training data that you use, where you have expert identified bird songs or ways of actually classifying recordings of particular birds and associating them with the birds that they correspond to. But the problem that I have is how do you actually put in place that continued learning where misclassifications get addressed in constructive ways? And now this could be human misclassifications, the experts might be wrong, but more likely this is sort of things that happen over time. It could be something that it wasn't trained on. We have a wonderful example of this where a friend of ours was using a birdsong app and it identified an extremely rare bird, and they tracked it down to find that it was actually a toad was making that noise. The noise was associated and misidentified. And I can absolutely understand that the bird app was identifying birds. It hadn't been trained on toads, so it didn't know that sound wasn't a bird, and was just saying, well, it's a sound. What sound could this be? Well, it could be, the best I have, the closest I have is this rare bird that makes a sound, which is maybe a little bit like that toad or not. And the key point is the following, that that's an example of things which aren't in the data. The toads weren't in the training data. And therefore, the differentiation between those birds and the toads couldn't happen because there was no training data to train it on. And so, more generally, if you have elements of thinking about a system which uses this into the future, how do you ensure that it doesn't continue to misclassify? And not just potentially between birds and toads, but between different, maybe within a species, maybe there's an evolution which happens and a change which happens to the song, and something, you're actually, there would be a different classification, but the algorithm can't know that. And so actually, as evolution happens, how can you build systems which would be robust to evolution? Now, with the post office example, if let's say handwriting evolved in such a way that people started writing a particular letter or number differently, well, this would happen automatically. Maybe the system would get it wrong for a while until actually these got fed back in, and then it realized, oh, that's how, I should now be identifying this with that letter or that number, because this would be getting back and caught up in the system as being wrong. But that is not easy to imagine how that gets built into these birdsong apps or to these systems. And so that continued evolution is so important to think through and to understand, how do we put in place these structures? And I struggle to see, if we are going to use, let's say, these apps for ecological conservation, how do we protect against these misidentifications, misclassifications, in ways that are affordable? Because otherwise it becomes an extremely expensive task to have experts go out and check things. So the whole point of using these apps is that you don't need to have that huge human effort. But I believe, and I'm not sure that if we actually get good apps that identify better, as is in the case of the post office example. Now, you can't use human experts because they may not be able to outperform the app, but that doesn't mean that the app is getting everything right. And so this element of being able to sort of think of how do we actually make sure we have learning systems in place, which are going to mean that not only does the algorithm perform now, but it's going to keep improving in the future. I don't have an answer for that related to these bird songs. I wouldn't know how to build responsible systems to keep improving these over time. I could work with people who might be more expert to try and understand what is possible. But right now, as somebody who doesn't understand birdsong but understands responsible AI, this is a tough task for me. I'd find that really hard.
I wonder. Oh, sorry.
No, carry on. Yes.
Well, I was going to say, I wonder, is it possible that it was more likely to misclassify for this rarer bird because it had less information on this bird because it was rarer?
I mean, it could be that, or it could be that it just so happened that that bird was the closest to that it had to the toad, and it's not been trained on toads, you know. And so it had to give an answer. It had something which could be a bird. What's the, you know, and it didn't have enough data on what this could be to be able to differentiate. If it had a lot of toad data, it would probably have been able to identify it as a toad. But the point is less. I'm less worried about that specific example because, you know, that example is potentially solved by having less narrow apps which are identifying just birds versus apps which might be identifying a whole range of animals and that are trained on a wider data set. And that would be desirable, and I'm sure that's the sort of direction that things are going. So the toad example may be resolved. I would expect that to be resolved in the future. Now, the example that worries me more is the example of what happens as things change over time. Because that's where I don't see these learning cycles. I could easily see the reinforcement cycles actually driving away from reality rather than towards it. And that's where I don't see how to ensure that as the system learns, it gets better and better, closer and closer to reality, rather than potentially getting sidetracked and going off in a direction which is different to reality. And that point is really critical.
Nice. Interesting. And so in a way, kind of, I'm trying to equate that to kind of the post office example on things changing over time and how that gets caught up. So maybe handwriting changing over time, but then you always have quite a wide variety of handwriting from the start.
No, but the point is, no problem with wide variety of handwriting. If handwriting does change over time,
yeah,
and the system misclassifies, it then goes to the wrong place. Because it goes to the wrong place, a human intervenes and says, this shouldn't be here, this should be somewhere else.
Yes. Okay.
And so that's where that learning is coming. That process, that very human process, is where things are going, when things are going wrong, is somehow, it's completely inbuilt into the post office, for examples. Whereas it's difficult to imagine that same sort of system within an app to identify birds or other species.
Sure. So thank you. And so from there, we have two other examples or two other case studies, which kind of we use to help show the limitations of AI.
And I guess both of these are, you know, these are more related to some form of scandal in different ways. Let's start with the Dutch scandal. I think the key point here is this was a very, I suppose, you described this quite well about this being this algorithm to identify people who were at risk of fraud of within child benefits. That's the sort of framing, really.
Yeah, it was looking at it was an algorithm which they didn't know at the time from I think it was 2013, which was looking at individuals that they thought were at risk of falsely claiming child care benefits.
Yes, exactly. And one of the key things in that is this element that the algorithm was identifying people at risk.
Mm.
And that's the data which it was fed in. And so basically the data it had related to the data of people who had benefits, and it was sort of then correlating in some sense and saying, aha, this has similar characteristics to people who had been found to be fraudulent with child benefits in the past. It didn't have data which allowed it to determine incidents of fraud. So it didn't have the data which would actually enable it to know this family is fraudulent or not. And I think that's really critical, that at the heart of this scandal is that misunderstanding of what the algorithm was set up to do. Now, as I understand it, there are criticisms of the algorithm anyway, but those criticisms aren't what led to the tragedy that really this caused. I suppose the suicides, the distress, the real human problems that emerged from this scandal.
Well, just also the thousands of children were put into care as well. That to me is a
Yes.
huge one, by just an algorithm saying, okay, this person is at risk of fraudulently claiming childcare benefits, and then the interpreted people interpreted that to mean this person is fraudulently claiming them, and so then they turn to them and they say, okay, we need that money back. And one person who had 3 children under the age of 6 said how they were given a bill for 100,000 euros. Someone else who was given a bill for 30,000 euros said that, and I think euro to dollar is roughly equivalent these days.
Pounds a little bit more, of course, and so you sort of
yeah. And so and this other one that got this one for 30,000 euros, and when they went to speak to the authorities to say, I think that there's been a mistake here, the authorities then stopped their other benefits, which just obviously made the situation worse, put them in a situation where it's okay, well, the more I talk to them about it, the more I try to fight this, the more I'm penalized. And that first individual that I mentioned with the 100,000 euro bill, she was given a she battled for 9 years.
Yeah. And this is the thing, that it's sort of this and the fact that this has gone on for over 9 years just shows how long some of these algorithms have been in use. And there is a much better and greater awareness now about regulatory frameworks which are trying to come in, which are making sure that actually these misunderstandings, these misinterpretations aren't happening. This is one of the scandals which the philosophers and others who are helping to draft those regulatory frameworks and helping to sort of put in place, particularly within the EU, the structures for more responsible AI, they're very conscious of examples like this. And so at the heart of this, to understand it, is this fact that even if the algorithm had been doing what it was supposed to be doing perfectly, the correct response to an identification of a family at risk of being fraudulent probably is to offer support which would enable you to determine whether or not they are being fraudulent or not. But that first step would almost certainly should have been a step of not assuming that they're guilty, but assuming that if they're at risk, there may be mitigating circumstances which are placing them at risk of being fraudulent, and therefore actually they may be a family which needs support, and to also be ensured that they don't become fraudulent because of whatever pressures they may be under. And so this is something where if you interpreted that as a sort of sign of families at risk, as opposed to families who are fraudulent, whereas what it was doing is it was identifying families at risk of being fraudulent. And I would argue that almost certainly, if you looked at the correlation between those and families who are at risk by other measures, they would have correlated. And so how you're interpreting it is really deterministic of the value of the algorithm. So the algorithm itself, if used responsibly, it wouldn't have mattered whether or not it was getting people wrong or not, because the response would have been a responsible response. And there you might have worried about the people it wasn't identifying as being at risk, because maybe they could have been supported and they wouldn't have been supported. And you might have been able to sort of reduce fraud if you'd treated the outputs of the model differently. And that's the heart of what I want to get to with this one. That and I do want to bring this back to lecturers, because if you're thinking about trying to identify students who might have, used AI for their essays or something like this, well, and you use a system which tries to identify those who have used AI, for example, or any other system. Well, if we recognize that these systems that are identifying students they might be identifying actual instances of cheating, or use of something that people shouldn't have been using, or they might have been, or in some cases it's been shown that they might be that these are students whose linguistic ability is different, and that sort of sometimes get confused with the identification of AI algorithms. So they might be a minority group in need. If the response were to be, let's say, you use your AI algorithms to identify those at risk of actually using AI in irresponsible ways, and instead of the response being they go to a disciplinary process, the response is they have now an oral session where you're actually having an interaction with them to understand what their knowledge is and so on. So this could be used as a way to identify people to have oral exams if you can't do oral exams with everyone. You use the AI systems to identify people at risk, and then those who are at risk of actually doing things in ways that you don't want, they could be then given an oral interaction as opposed to a written one. And what you might find is that you're actually increasing the value of the education which is given in a very sustainable way. And I think, to come back to the fact that the Reading study, which only identified 2 out of the 33 to be AI generated, if we sort of tried to identify more, so let's say you knew that 33 were AI generated going in, and you then try to identify 33, is you might have more people who actually were identified as AI but weren't. It was their own work. Then if you misclassify those, if you've got it as now sort of chucking them out of the university, it's totally unfair. Whereas if your response is, well, we need to have an oral examination, and nobody turns up because it was AI generated and a fake student, so be it. Or somebody turns up and they don't know what they've written, they don't understand what they've written, they can't justify or interact with what they've written, then that is something where then that warrants the negative connotation. Whereas somebody who comes in and really knows their stuff and has understands what was there or not, does it matter if they used AI or not? That's maybe not what's most important. What is most important is the education value which comes out, and really to recognize that when we use AI tools, just as when they get used in contexts which have led to some of these scandals, it's how we interpret the results and how we use the results that matters. And that's, I think, a really key point I'd love people to take out from this.
Absolutely. I think you phrased that so well. I've not thought of it in that context either. So yeah, really.
I think the parallel is really there for
Yeah,
lecturers.
absolutely.
This is a really good warning that, interpret it right, use it as a tool which helps you, but be careful.
Yeah. And never let the robots have the final say.
Yes.
Just like last week when we were looking at the polishing and everything, or the robots generating things for you. Well, you still need to fact check that, or the robots tidying up some scripts for you. You still want to reread that, make sure that you are happy with how it's done that.
And done well, we keep coming back to, and I guess this is going to really come out in the next few weeks. Done well, using these can make us more efficient and effective, which I suppose brings us nicely on to the next one.
Yeah, which is Amazon Fresh. Just walk out.
And this was something where it was beautiful what happened recently. I was never that excited by Amazon Fresh because the thought of cameras sort of monitoring everything I'm doing all the time in a supermarket never really appealed to me. But what happened recently has changed my perspective on this completely, because now it's one of my favorite examples of the limitations of where we are currently with AI. And I want to be clear that what they were trying to do, I believe, is possible. It's just it's the limitations of the current technology mean we are not yet there.
And so let's start with what they were trying to do, and that was, I mean, my understanding is yeah, I actually tried it since reading this article. I tried it out. I've only tried it out once, but I tried it since reading this article, and I found it hilarious. Now knowing after the scandal about things, but you walk in, and you pick various things up and you put it in your basket, and then you scan on your way out. You scan something linked with your Amazon account, and then a few hours later, you get a text saying, okay, we've now taken out £3 or however much your shop came to that day.
Yeah.
There's no tills needed. You just walk around, you pick up what you want, and it's called just walk out. And I guess the idea of what it kind of the impression of how it was sold, at least to me initially when it first came out many years ago, was that it's AI powered, that they can detect from weights or something of what has been picked up and what's been used.
Yeah, they were using all the data that they had at their disposal, the cameras all over the place, and all sorts of other things, to try and actually determine what you picked up and what you've used. And in practice, as I understand it now, with some of the details which have now come out, is that this has been now changed, or recognized that this wasn't working. And what do we mean by it wasn't working? Well, actually, what had happened was your tills had been replaced by low-paid workers in India who were watching you as you shopped to determine what you picked up and to put that on the list. And the whole point was supposed to be you could then check through, had they got it right, and do you accept that this is what you took, and so on. But of course, it's a really tedious process, and so really you want it to work really well. And there were all sorts of other issues around this, but the idea originally was that actually, with enough information, with enough data, the AI algorithm should be able to be trained to be able to know what you've taken and just do this for you. Whereas in practice, and the idea was that these sites in India and elsewhere that were actually analyzing the videos manually and coding them up as to what you took, this was just to train the AI algorithms. But the algorithms weren't able to get good enough. Now, I think, like the post office, this is a solvable problem. This is something which, with time, I believe, in the right ways, you could build something like this. Do we want to? I am not clear. I'm quite happy that at the moment we're not in that direction. So do I believe that we will have the capability of building such a system at some point in the future so that it works and so that actually AI can do this? Yes. Do I want us to? I'm not sure. And this is one of the things where I don't know. And what I do know is that when we think about what AI can do and can't do now versus in the future, that line is moving very fast. And really, it isn't the right line for us to be worrying about. My hesitance with wanting to use such a shopping system is more because I'm not sure I want what I'm shopping to be determined based on all the cameras which are filming me from every single angle as I shop, because that's what's needed to train a system like this so it can work. And I just don't know that that's what and to train that, people will need to watch this. I don't know that that's the jobs that I want in the future. Actually, to train a system, you could train the same sort of system based on a sort of scanning sort of system, which you currently have in many supermarkets. And I think this is what Amazon Fresh has moved towards, where it's got a scanning basket. You put something in the basket and it scans it as it goes in. Actually getting to the stage where you build an AI system on the back of that, rather than a whole load of cameras, I'm much more comfortable with. Now, there's, of course, elements about data quality. There's elements about honesty about that, because there are issues there. But these sorts of things are things where it matters how you do it. And this is key again. So now let's come back to how this relates to lecturers, because for lecturers, it's not about Amazon Prime and it's not about Amazon Fresh and the shopping. What is it about? Just because there's ways we could use AI in education doesn't mean that they are all going to benefit education. Yes, we can use AI in powerful ways to improve education, just as we can use it in other areas of our life. But that doesn't mean that all of them are, or that because it could improve education, that it will. And implementation matters, details matter. To me, if you're shifting the training to these sites where you're offshore, where people are watching videos of other people shopping, that is not the correct way to do it. Similarly, if we were to build AI systems for education which sort of bypassed teachers and relied on people who were totally removed from the teaching to be able to do the system learning, I would argue, I'm not sure that's what I want, because I want the learning from the system to be localized. I want it to be coming from the humans involved. I don't want to lose the teachers. I don't want to lose lecturers. That's where how we build these systems matters. It's not just the result we head towards. It's how we choose to build them. And that's critical. And so, to me, the reason I am delighted in the failure of Amazon Fresh is not because what they were trying to do was something that was wrong. It's how they were trying to do it goes against my ethics of what I believe is a responsible way to build such systems. And that's something where this is subtle, but it's so important, because we are getting bombarded with tools which are AI based. And the devil's always in the detail. Are we building tools? Are we training tools? Are we keeping humans in the loop in a way which coincides with how we want society to integrate AI or not? And those are questions which are really hard. And I don't hear people discussing them. But this is part of what I want to do, and in terms of demystifying AI for people, is to recognize that at its heart there are human processes within AI systems. It doesn't matter which big AI system you're looking at, there are human processes behind it. How those processes work is really what matters. And that's one of the key things that we should always be thinking about when we're using these AI tools, because it will affect how they work, and it will affect the nature of the learning behind the system. And this brings us back to this element around our first two examples. If we go back to the overview, that really, to me, the difference I want to articulate between the post office and the birdsong example is that in the post office example, we have humans in the loop to be able to correct errors, which means that the system is going to evolve in ways which will match with our societal needs. They're localized almost by definition, because the post is localized, and so on. Amazon Fresh, to me, they could have chosen how to go about this, either by thinking about trying to go towards this system through learning based on human systems that we know and like. What if, for example, they did build an AI system, whereas instead of it being done by people in India, they actually had people going through the tills normally, but they just gradually actually sort of said, we're going to do 2 years or more where we're trying to train to see how well does the sort of does this match against what actually comes out of the tills. That would have been a much better, more ethical way to do exactly the same thing. But we as a society are not thinking about that at this point. We're often carried away in AI as being this amazing new thing, rather than recognizing that it's not, it's just an evolution. And it's something which needs to fit into our societal. It doesn't need to be totally disruptive. It is disruptive, but it can be done and integrated in ways where the learning component is then thought out and thought through. So it could be that you actually have a process whereby for the first while this process happens and it all goes through the tills, and then over time you then get sort of, when you come to the tills, you then get a sort of a percentage by which you have confidence that your shopping needs to go to through the till or not, and so you get, as you come to the till, it tells you whether you need to go to the till or not. And then gradually you can be training the system based on data, which would, I think, be much better data in the first place. And, even if that was done by cameras, it's not being watched by people. The training is happening on the outcome, which is what we care about. And so the same process, the same learning can be done in different ways. And this is where we need to be thinking very critically about not just what we're using AI for, but how we're using AI and how we're integrating it into our systems. And that's something where I think, imagine instead of doing this as Amazon Fresh is a big deal, imagine you were doing this in your big supermarkets that already exist, where when you got to the tills, you now got to a point where occasionally it would say, this is what we think you've got. If you agree with this, you can just pay for this and go out. And, this is something where, as a way to introduce it, that would be much healthier. And the learning could have been done in a much healthier way. And so we need to not only think, as we're thinking about integrating AI into our teaching and learning and into our society, we need to be thinking about what it does, why it's powerful, what its limitations are, what happens if we don't get the right learning systems in place. We need to be careful about the interpretation of it and how humans use it. And we need to think about how we are building responsible ways to integrate it into our society, so that it is integrated in ways which are positive and, you know, of benefit to society, rather than detrimental. And so I believe these 4 cases do cover what the things I hope people will take out when they think about knowing, you know, what AI is, what it can do. It's a tool. It's an extremely powerful tool, you know, and it will transform our society, just like innovations have in the past. Electrification and having electricity is an extremely powerful tool to be able to have access to that in your houses. You know, AI is an extremely powerful tool. It is disrupting education. For you as lecturers, you know, I hope you understand enough about what it can do, the fact that it has and will always have certain limitations, the fact that how you interpret it matters, and how we as society integrate it matters. If we're aware of those 4 things, I'm more optimistic about AI in our society. So anyway, I hope this is of value, of use, as you're getting into using this in your teaching and learning. Next week, we're going to get down a bit more to actually concretely, you know, for education. Is it a friend or is it a foe?
Perfect. Thank you very much, David.
Thanks, Lily. This has been good.